Today, lesson 17a, multiplying integers. And today's a day, and this is not the first time that we've run into this situation, but many of you were in honors last year, but some of you were not in honors last year, but you made it to honors, which is a great thing. Those of you who were in honors last year, you guys did all of the integer operations. I'm very aware of that. And so today's a day where, once again, we're going to use some modeling to prove why the answer is truly what you say that it is. And I'm bringing that up because those of you who are in honors, I realize that you already know the rules for multiplying and dividing positive and negative numbers. Okay, I get that. But much like some of the other times where we've used modeling to prove why the answer is what you say that it is, we still... if we're asked to model, we still need to do the modeling just to prove that it is. And as you've already found out, I'm not making you model every single problem like you may have had to do in the 5th or the 6th grade. But if we are asked to model, we need to make sure that we do model. Okay? All right, so today we're going to be determining the rules for multiplying integers. And I know those of you who are in honors, you know the rules. You probably don't know why the rules are what they are, but you were just told to memorize these, and you did, okay? And so today's a little bit of investigation as to why those rules are what they are, okay? All right, so let's go ahead and get started. A little bit of background knowledge from last year. We already did some background knowledge on the commutative property where we can flip-flop numbers around addition. Well, that also applies to multiplication. I talked about the fact that that does not apply to subtraction because 6 minus 2 is not equivalent to 2 minus 6, but we can flip-flop numbers around addition and multiplication. Another property you talked about in 6th grade that we haven't talked about yet is the associative property. And the associative property is where regrouping is okay. In other words, you can regroup numbers together using parentheses. Associative property, like the commutative property, works for addition and multiplication. And it's a little less clear for most of you with letters, but if I use numbers, it should be clear to you that the left side is equivalent to the right side. The left side, I was grouping the 4 plus 2 together. In the right side, I'm grouping the 2 plus 9 together. Notice that the numbers did not change order. It's the grouping that has changed. And the associative property also works for multiplication. And we're going to utilize both of those properties today to prove why the rules are what they are for multiplying integers. So if you weren't in honors especially, you need to take very good notes today to make sure that we're very clear on all of these things. All right, in 3rd grade, you first learn how to do multiplication. This means 3 times 5. This is another way of writing 3 times 5 with a dot, and that's a third way of writing 3 times 5. There's always multiple ways of writing multiplication problems, but all of those represent 3 times 5. And 3 times 5 can be thought of as 3 groups of 5. So there's one group of 5, and so I'm using plus symbols since we're talking about positive numbers in this problem. But there's one group of 5, there's a second group of 5, there's a third group of 5. So 3 times 5 can be thought of as 3 groups of 5 positive symbols, and if we counted them, obviously there are 15 of them. Another way is by doing repeated addition, writing 5 down 3 times and then adding them together. So that's what we sometimes call repeated addition. And you may not remember learning both of these ways, but I guarantee you in the 3rd grade you did. Okay? Well, the commutative property of multiplication tells us that 3 times 5 is the same thing as 5 times 3. And that's kind of common sense. Okay? Common sense. 5 times 3 can be thought of as 5 groups of 3, and all I'm doing here is I'm thinking about that multiplication problem using the commutative property, and it's clear that we still have 15. 3 groups of 5 or 5 groups of 3, you're still going to end up with 15 there. And so we're going to utilize this thinking today to help us with proving why the rules are what they are for negative numbers as well. So here we have 4 times negative 2. Here's another way of writing 4 times negative 2. Here's a third way of writing 4 times negative 2. Lots of ways of writing 4 times negative 2. 4 4 times negative 2 can be thought of as 4 groups of negative 2. There's one group of 2 negative symbols. There's a second, there's a third, there's a fourth. How many negative symbols do we have altogether? Let's try that again. That's not a trick question. How many negative symbols do we have? 8. 8 of them. Okay? And then we could also use repeated addition like you learned how to do in the 3rd grade. 4 groups of negative 2 means we have 4 negative 2's that we're adding together. And as we already saw from adding integers together, that would give us negative 8. So we've now proven in 2 different ways that 4 times negative 2 is negative 8. Okay? We could also do this with a number line. With a number line, we're going to start at 0, and we're going to move in the negative direction 2 units at a time, and we're going to do 4 of those jumps. And that leads us to negative 8 on the number line. So some of the problems in today's notes, I'm going to have you prove it with tiles, some with repeated addition, some possibly with a number line. So we can use many different ways of proving it. So now we are officially at the very first problem in your notes. It says, perform each of the following by using symbols, repeated addition, and a number line. I want you to do it once with 3 times negative 3 and once for 2 times 5. And I'll give you about a minute and a half or so to get that done. And then we'll take a look at it. For 3 times negative 3, we are supposed to use symbols, repeated addition, and with a number line. So with symbols, that would be 3 groups of negative 3. So 1, 2, 3, 1, 2, 3, 1, 2, 3. And it's clear that the product there should be negative 9. Repeated addition would be 3 groups of negative 3. Negative 3 plus negative 3 plus negative 3 is negative 9. On a number line, 3 jumps of negative 3. 1, 2, 3, which leaves us right here at negative 9. For 2 times 5, that would be 2 groups of 5 positive. So 1, 2, 3, 4, 5. We could also think of it as 5 groups of 2, utilizing the commutative property. So that proves that that's 10. With repeated addition, 2 groups of 5, so 5 plus 5. That's another way of proving that it's 10. And 2 groups of 5, so 2 groups. I'm a little off there, but I think you get the idea there. So 3 different ways of proving each of those multiplication problems. So that should seem pretty easy. Now, next problem would be, and this is not in your notes, but just look up here. We have negative 4 times 3, and that's 3 different ways of writing negative 4 times 3. Now, one of the things you could do is you could just do this with the commutative property and flip it. In other words, make it 3 times negative 4 and do this the same way that we did the previous problems. But I'm not going to do it that way. I'm going to do this by a different method that I call opposite multiplication. So this can be thought of as the opposite of 4 times 3, or something like this. Now, if I utilize that thinking, I can now regroup, in other words, use the associative property and multiply the 4 times 3 together first. By the way, what's 4 times 3?
12.
And then what's the opposite of 12? Negative 12. So that's one way of proving that negative 4 times 3 is really negative 12. And that's the reason why using opposite multiplication. Now, once again, you could have used the commutative property and thought of it as 3 times negative 4 and used one of the methods that we've already talked about. But this is opposite multiplication. All right. Once again, that's 3 different ways. And here's kind of a way of doing it quickly in your head. The opposite of 4 times 3 is the opposite of 12, and that's negative 12. Or, like this, the opposite of 4 times 3, which is 12, is negative 12. And I'm just in case you get these multiplication problems written slightly differently. And all this writing I'm doing is kind of doing that part in your head. Okay? If we were to do this with a number line, commutative property allows us to think of 3 groups of negative 4, which I already talked about. So there's one group of negative 4, there's a second, there's a third, and that takes us to negative 12. All right. Is this one in your notes? No, it's not. Okay. So I'm going to do this one once again with the opposite multiplication idea. This can be thought of as the opposite of 2 times negative 8. The opposite of 2 times negative 8. Well, if I utilize the associative property and group the 2 times negative 8 together, that's negative 16, and the opposite of negative 16 is positive 16. So negative 2 times negative 8 is positive 16. And once again, the opposite of 2 times negative 8 is negative 16, and that is 16. And same thing on all three of them, since they all represent the same exact idea. With a number line, I'm going to use a vertical number line this time. We are finding the opposite of two groups of negative 8. Well, here's one group of negative 8. There's a second group. That gives us negative 16, but the opposite of that is way up there at positive 16. All right, these two I know are in your notes. Find the product of each of the following with a number line. We're going to go through all of the methods as we go through the different problems here. When you shoulder partner, you have a sentence frame up there. The product of blank and blank is blank. Obviously, you're not using the word blank. Anybody want to take a shot at number one?
The product of 6 and negative 3 is negative 18.
Good. And using a number line, we're going to go 6 groups of negative 3. There's 1, there's 2, there's 3, there's 4, there's 5, there is 6. We're right there at negative 18. So the product of 6 and negative 3 is negative 18. How about number 2?
The product of negative 7 and negative 2 is 14.
All right, very good. And the way that we're supposed to do this with a number line is we're thinking about this in terms of the opposite of 7 times negative 2. 7 times negative 2 is 7 groups of negative 2. So 1, 2, 3, 4, 5, 6, 7, which is at negative 14. But we're dealing with the opposite of that. And the opposite of that, of course, takes us way down here at positive 14. So using a graph, that's what the graph should look like for number 2. Any questions on either one of those? Okay. Let's move on. Number 3 and 4, it says prove that your answer is correct with opposite multiplication. This should take less time. Go. And then I'll have you compare with your shoulder partner. In both of these, you were supposed to use the idea of opposite multiplication. So, number 3, the product of negative 9 and 6 is negative 54. And the reason is because we're finding the opposite of that times that. 9 times 6 is 54. The opposite of 54 is negative 54. In number 4, the the product of negative 7 and negative 6 is 42. The reason is because we're finding the opposite of 7 times negative 6. 7 times negative 6 is negative 42. The opposite of negative 42 is positive 42. All right, let's turn the page. 5 through 10. It says, prove that your answer is correct by one of the following. Either a number line or repeated addition or symbols or by opposite multiplication. I don't care which method, but pick a method, and I would like you to do all 6 of them. This should not take very long, and then we'll compare with our shoulder partner. They are. So number 5.
Number 5. The product of negative 3 and negative 14 is 42.
Very good.
The product of 12 times negative 7 is negative 84.
Okay, good. Keep going.
The product of 8 and negative 12 is negative 96.
All right, good.
The product of negative 7 and 4 is negative 28.
All right, let me get to the next screen here.
The product of 6 and 12 is 72.
All right, and?
The product of negative 5 and negative 9 is 45.
Okay. So this should seem very, very easy. And I know, as I mentioned earlier, those of you who were in honors, You learned the rules last year. You may not have learned why they are what they are, but you learned the rules. And so if you weren't in honors, the big question here is, have you recognized any patterns when multiplying integers? Well, is that a yes or a no? Hopefully. Hopefully by now you have noticed a pattern. If you have not, use one of the methods we have discussed today. And that's why I've been forcing you in the notes. If you're not asked to model, then you can just go straight to the answer because hopefully you have recognized a pattern. So right now I want you to put your pencils down. I have 4 problems up here. I want you to think about them for a second. And I want you to exchange what you think the answers are with your shoulder partner. Go. All right, so 2 of them have answers that are positive, and 2 of them have answers that are negative, right? Which 2 are the ones that have answers that are positive? Which 2?
The negative?
The negative? What do you mean? 3 of those problems have negatives in them.
6 times 2 and negative 6 times negative 2.
Yeah, those are both positive. And then the other 2, negative 6 times 2 and 6 times negative 2, those have answers that are negative. And so what that leads us to is basically this idea right here, that a positive times a positive is what?
Positive.
A positive times a negative is?
Negative.
That was a long negative. Yes. And a negative times a positive is?
Negative.
And a negative times a negative is?
Positive.
Yeah, and the y part of it is much like we discussed early in the lesson. You can prove that with symbols. You can prove it with opposite multiplication. You can prove it with number lines. You can prove it with, what's the other one? Repeated addition. Any of those methods are perfect for proving them. Okay? All right, do 11 through 15. And then after that, we've got one last thing left to talk about. Number 11, the product of negative 5 and negative 3 is positive 15. Number 12, the product of 8 and negative 4 is negative 32. Now we have some problems with 3 numbers in them. I don't know how all of you did them. Some of you probably went left to right. But, you know, we have the commutative property, which tells us that if we have straight addition or straight multiplication, we've already talked about the addition idea. With multiplication, you can do the same thing. You can go out of order if you want to. So if you wanted to, you could say, well, I think I want to multiply these 2 numbers together first. The product of negative 3 and 5 is negative 15. And so now we have 2 times negative 15. And the product of 2 and negative 15 is negative 30. So in straight addition or straight multiplication, it is the commutative property that allows us to go out of order. Number 14, the product of negative 2 and negative 1 and 6 is positive 12. And number 15, the product of negative 7 and negative 2 and negative 3 is negative 42. Okay? All right, last thing for today, we now take this to word problem situations where we will convert to some sort of math problem and then find the answer from there. Just a little bit of background knowledge. This was from a lesson earlier in the year. It's also from 6th grade. All of these sentences or word phrases can be represented with these integers. And we've run into this sort of idea more than once so far this year. And so now let's take a look at number 16. It says write a multiplication problem for each situation and then write the answer as a complete sentence. We'll do number 16 together. You borrowed $7 each from 8 different friends. How much money do you owe? Well, a multiplication problem that would represent that situation might be borrowing $7 is negative 7 as an integer from 8 different friends. So you're going to multiply that by a positive 8. And it should be obvious at this point that the product of negative 7 and 8 is negative 56. It does say write your answer as a complete sentence. That would be something like you owe a total of $56. All right, can you do number 17 and 18? We'll then compare with our shoulder partner, and then we are finished for today. The temperature decreased 4 degrees per hour for 8 hours. How many total degrees did it decrease after the 8 hours? A math problem that would represent that situation would be the product of -4 and 8. Of course, that product is -32. And so a sentence that represents that situation might be something like this. The temperature decreased a total of 32 degrees. Number 18. During a recent deep sea dive, you descended 5 feet every minute. How many feet did you descend in 12 minutes? That could be represented by -5 times 12, which of course is -60. A sentence that could represent that situation might look like this. You descended a total of 60 feet. All right, turn to your shoulder partner. What did you learn today?